Hi, my name is Vidya. I'll be offering this course called Digital Speech Processing. I have 16 years of teaching experience and 2 years in industry. I have been working with speech maybe for around 10 years right now. I have been offering speech processing as a course, pattern recognition, and subjects that are, related to speech. I have also handled projects that are related to speech, like advanced audio coding in industry. So I thought I will give this course. I will offer this course. So let us move on to the course. I'll be using the first textbook that I've mentioned here, Theory and Applications of Digital Speech Processing by Rabiner and Schaefer. I will also be using the second book as a reference, Discrete Time Speech Signal Processing by Quartieri. This is more mathematical, so I will be using only as a reference. My first book will be the main textbook here. So a lot of things that I'm going to share in the slides will be from the textbook, from the first textbook, Rabiner and Schaefer. Now what you will learn in this course is how the speech waveforms look in different domains, time, frequency, or even other domains that we will learn later. We will learn different DSP techniques, digital signal processing techniques, that will teach us about speech. So, we can learn its different representations, we can learn how to analyze it and how to use that information better. We will also learn digital representations and algorithms, which is more like your MP3 AAC coding, which is a digital representation of speech. So we will learn how to digitally represent speech in a compressed form, what are the algorithms used in that process, and so on. And last but not the least, we will also learn some applications. So very few applications, I will also include them in this course. So this is going to be the flow of my course. So I will start in this video. I will give a short demo about how speech looks. So let us see how speech looks. I have put waveforms here. So you can see two waveforms. The first one that you can see on the left is my voice when I uttered should we chase. So you can see here I have uttered should, here I have uttered we, and here I have uttered chase. There's a small blip in the microphone in the beginning. Other than that, you can see the waveform should we chase. I have enlarged the portion here where I said we. So you can see that speech has a lot of silence. So in the waveform, you can see a lot of silence. Silence is something that we don't need to encode, we don't need to transmit. So we need to understand how to handle silence and how to handle the speech portion. Now, even in the speech portion, I have enlarged the portion where I said we. And you can see that it looks periodic. So usually 20 millisecond of speech looks periodic. That is because of our vocal cords vibrating. So it has a periodic look, and that is why it is called quasi-periodic. So it is periodic for a short duration of time. And that is what we see in this waveform. So I have recorded 3 seconds of the waveform. So as you can see here, and I have shown you the waveform when I uttered should we chase. Now let us see the same thing in the spectrogram domain. So in the frequency domain here, the horizontal axis shows time and the vertical axis shows frequency. Again, you can see there is a small blip here, and here I have uttered should, here I have uttered we, and here I have uttered chase. You can see the portion where I have uttered should. So you can see the portion here where sh comes. Now here, that is a portion where your vocal cords do not vibrate at all. When you utter sh, you can just try that. So your vocal cords do not vibrate when you utter that, and that is called unvoiced. And you can see that from the spectrogram, if you see the other portions, you will see horizontal lines here, which is denoting the pitch and other formants, but you will not see them for the unvoiced portion. So here you can see should, then you can see we, and you can see chase. Now in chase, again ch and s, chase. You can see the initial portion is unvoiced, and again s is unvoiced. So you can see this. So what we are going to learn is how to handle silence, how to handle voiced speech, how to handle unvoiced speech. So all this we will learn. I will show you a short demo where I have already written a MATLAB code that gives us these outputs, and I will share that code with you. I would want you to change the different parameters there and try different utterances and see the waveform, how it works for different utterances. So let us move to the MATLAB demo right now. So this is the MATLAB code where I have written the same, we are expecting the same output. So I will run this code. I will again utter should we chase. Should we chase? Should we chase? So you can hear the output. I have played the output back. And this is the time domain waveform. I have 3 seconds of speech and I've uttered should we chase. You can use this magnifier to magnify a portion if you want. And you can see the periodicity in that particular portion. So you can see that speech is quasi-periodic by doing that. So I would like you to just play around with this with different utterances and see how it looks. And here again in the spectrogram you can see here there was a blip and then there is a should we and then there's a chase. So you can see those portions here. You can see the voiced portions and the unvoiced portions in speech. You can also see the silence. Same way here you can see the silence. So if you just look at the code, what I have done here is I have selected the sampling rate to be 16,000. I am using an audio recorder which will record samples at 16,000 samples per second. I have told that I want 16 bits for each sample and I want mono. So that is the recorder setting, and then I am recording it here for 3 seconds. So this 3 means that. Then after recording, what we are doing is we are taking the recorder data and saving it as M. Here I have plotted the time domain waveform. The horizontal axis is time and the vertical axis is the message M. And there's another figure where I'm plotting the spectrogram, and these are all the default settings. So you can see that I'm plotting the spectrogram of M with a sampling rate of Fs. The function sound plays back what I have uttered right now. So I would want you to try this with different utterances and all that. So with different sampling rates and with different, the number of seconds can be different and the utterance can be different. So please try to, I will be sharing this code. So please try to play around with this and learn speech better, the representation of speech in time domain and in frequency domain.